So I'm Sandor Felber from Minerva Humanoids. We're building humanoid robots for the most dangerous jobs of the planet, including oil and gas, energy sector work, public safety work, disposing of bombs, chemical units, hazardous material disposal. And we're on a mission to do that with deployments actually before the end of this year, and some scaled real product available sometime towards the end of next year. So before I start with the opening frame, I'd like everybody to give a quick one-liner of each other, and then I'll introduce the panel.
Yes, thanks for the introduction. I'm happy to start. My name is Florian Weishardt. I'm from Synapticon, so we are a Germany, Stuttgart-based company providing components to humanoids from drives, actuators, and also a full system safety solution. My background is in software engineering for mobile robots since 15 years. And of course, that can drag along to humanoids now.
Hi, everyone. I'm Ilya Tolchinsky. I represent Synopsys. We provide software solutions for simulation, covering everything from silicon to systems, complete systems. My background is in aerospace engineering. I used to do design. I've done software, particularly safety-critical software. So I have that perspective. And now I'm the product manager for AI for Synopsys.
Hi, everyone. I'm Arnab from Saphira.ai. We are a Silicon Valley-based company working on automating functional safety and security workflows. So we spend most of our time really trying to bridge those two worlds and make sure that embodied AI is an inherently safe and secure product. My background is I've spent most of my career as a systems engineer in automotive and robotics. And yeah, that's basically what we're now moving into the humanoid world as well.
Hi everyone, my name is Jason Yueh, CTO of VicOne. VicOne is a subsidiary of Trend Micro and specializes in physical AI security, such as automotive security or robotic security. And prior to VicOne, I was the chief architect of Trend Micro. Thank you.
Amazing, thank you all. So I would like to introduce the panel, which is about securing the machine and also about safety. So first, I would like to outline those two concepts and maybe have you guys also pitch in a little bit and helping me build an understanding of what safety and security means and how they are different. Firstly, my perspective has been that security is the attack path, but safety is actually hurting people next to you potentially and making sure that you're not actually falling on them. So security really concerns itself with potentially the building burning itself down by some malicious attack vector surfacing itself within your humanoid robot and doing things that are not great to your building. Whereas safety is more about how do we make sure that during normal operation and potentially when compromised, how do we make sure that humans around the robot do not get hurt, and just generally more about the public safety as well, given the fact that we're doing a lot of work in that space. Yeah, so would you guys agree with that concept? Is there anything you guys want to add to this?
Yeah, I think the functional safety part that cares about the human. So the only thing we care about is that no human gets injured. And the security part, that's also for protecting data, protecting values. But in the end, functional safety is just about preventing humans from being injured. So we don't care if the robot breaks. And if the building breaks down, it's just about the humans inside that environment.
As systems get more and more complex and we start adding more layers of autonomy and AI into these systems, the security risks also start growing exponentially. So it is very important to understand and manage your system's security and safety risk, right? So what security compromise leads to what safety event? If it is a safety event that doesn't affect your safety case, you probably don't have to pay attention to it, but you need to know that consciously, right? This is about making sure you understand your security and safety posture, make sure that you have a clearly defined security and safety posture with the product you're putting out there, and understanding how you're going to actually make sure your product complies with that. It's not just about building guardrails for your AI, but it's also about making sure that when those guardrails fail, there's an actual safety mechanism that stops the robot from, as Florian said, hurting human beings or violating your safety case that you set up. So having this whole system end-to-end in a dynamic fashion that lets you make decisions at rapid speed is important, because hackers don't stop, right? People are going to keep trying to hack systems. There are different ways to spoof systems these days. The more intelligence you add, the more opportunity you open up for different security vulnerabilities. So keeping on top of those and making sure you understand their impact is absolutely key.
I second on that. I think security and safety cannot be two separate work stream. Yeah. So safety is about deterministic failure, and security is about undeterministic failure, manipulated by attackers. Yeah. So I would say security, especially cybersecurity, is one of the fundamental pillar of safety.
Maybe just to add that when I think about the interaction between the two, security is dealing with a malicious threat, right? Safety is often considered just, like you say accidents happening, making sure your system is going to behave and not cause any injuries. But you really have to consider malicious threat and its impact on safety.
Absolutely. Thank you, guys. So 3 years ago, to just take a look at what this space looks like at the moment, 3 years ago, it really was, data was really the final layer of all kind of safety and security problems. Robotics weren't really going to come out of the labs, and now they are, right? So now that data poisoning or red teaming attack that is a lot more serious, that can actually become a whole issue. It can literally take down not just a single company, but potentially investor kind of belief and confidence in the entire sector. So we all sort of have this responsibility and this mutual care for not doing that. But at the same time, we also don't have defined standards that we need to abide by, and there is clear market competition that's global, right? So that's the pressure under which most robotics companies operate today. And I think one of the really important aspects of this is really how can our robots be abused or potentially put to something that's malicious. So I would like to ask to the panel what an attacker can do to an intelligent, potentially humanoid or other form of a robot that can be potentially malicious. How can we mitigate these threats? And what has really changed over the course of the last 3 years? What has been the biggest trend that you guys have seen that's really exposing that vulnerable, that threatening surface that we need to protect ourselves against from a security standpoint?
Yeah. I think vehicles are probably the first connected intelligence machines deployed at scale in the real world. Yeah. And vehicle already tell us what can go wrong. I just give an example. In March this year, around 100 Apollo Go robot taxi flew simultaneously on the elevated highway or the major intersection in Wuhan, China. The root cause was not disclosed, but we know there must be a mechanism that can freeze the entire fleet at once, right? Yeah. And talking about robotics, we all know that last year there was a warmable Bluetooth vulnerability discovered in the Unitree robots. Actually, they have a booth out there. I believe they already patched it. And you just need to compromise one robot, and that robot become a moving attacking station, right? Imagine that robot return to the shared charging station, and that robot can use exactly the same Bluetooth vulnerability to compromise the rest of the fleet, right? Yeah. So physical proximity is no longer an excuse to ignore that kind of threat. And I think in recent years, the trending is about AI. Nobody will argue about that. And we all know that AI models are not perfect. It can be fooled by prompt injection or adversarial image patches. And we'll soon be seeing that people start to deploy AI agents onto the robot to handle more complex tasks. You know, that will introduce new risks like indirect prompt injection, malicious skills or MCPs, right? And actually, there were over 300 malicious skills discovered in this February on the Cloud Hub, the Open Cloud registry. This February, yeah. So you don't even need to compromise the robot. You just interact with them, right? Yeah, you can, then you can mislead them. So what I want to say is those attack services and threats and attack mechanisms are there. They are real. But this time it's about safety. And you don't want to wait until it happens, right? Yeah.
And maybe to add to that, you said that the humanoids are much more complex and much more capable today compared to 3 years ago. So that's also what we see as a difference compared to industrial robots, cobots, or AMRs. Because if you have an industrial robot, that's typically screwed to the floor or to the ceiling. So if that gets hacked and gets unexpected movements, you will know that the area where you can have people injured is limited. That's similar for AMRs. So they typically are big, bulky, so they just have a limited operating space. So they probably have few chances to escape the actual factory hall or climb upstairs or go down somewhere. But if you think of humanoids today, they might just climb the stair. They might just open the door, and then they can basically be everywhere. So the risk is not is not anymore limited to a certain area where you operate the robots. They can basically operate everywhere. And that's what I see as a big difference for the functional safety part. So, yes.
And I think just to add to everything my colleague said here, we have to keep in mind the way you actually threaten or create threat paths to these machines is also evolving, right? So you have the very sophisticated attacks where you could build agents to attack, but you can also actually just misuse the intended function. Just as an example, like last year, people in San Francisco were buying T-shirts that had a stop sign on them and standing on the side of the road when a Waymo passed by, and the car would brake, right? That is not a failure. That is actually what, if the car sees a stop sign, it is supposed to stop. But people were now spoofing this, right? This is, obviously security is a non-deterministic thing, right? No one who worked at Waymo thought that this was going to be the issue they'd be fighting, but that was the issue you start fighting. So your threat landscape is going to evolve, and the number of threats you're going to have to deal with also will evolve. Now, as a company, as a robot manufacturer, as a humanoid manufacturer, you have to really make sure you're prioritizing correctly, making sure that the safety issue caused by these security events is something that you should be mitigating, or if there are ways around where you think that is not a part of your safety case, maybe those are not the places you should spend your time. So it does also come back to an optimization problem, especially as you scale your product.
I think we're in a phase where we're discovering the unknown unknowns, right? And it will take us some time for these things to surface, and I'm confident we will address them as they come up.
Awesome, thanks. So for a case study that the audience might be familiar with, we have seen a powerful model being tricked into writing safety critical software for against a government, a national security system, and it was able to achieve really impressive results. As a result of which, the government under which that company was operating, they decided to take down the model for 3 weeks and then put it back on the open market. My first question to you regarding this: can we actually prepare for a future attack by an AI model that has capabilities that we are not aware of?
I think we have to be prepared for events like that. In general, again, the guardrails that we build around the system is probably step 0. We cannot send a system that actually interacts with the physical world without guardrails, but we need to make sure we have mechanisms in place that actually make sure the system is safe when those guardrails fail. Now, understanding what the failure of that guardrail can lead to and what the proliferation of that can be in terms of safety events, that is where this becomes key. Earlier, you could have very deterministic, linear safety events, right? So if a brake fails, those are the things that happen in terms of safety. If there's a misdetection for a vehicle or a misdetection for a humanoid, the following things are an issue. But as we scale these models and essentially get them to start hacking the systems, we need to make sure we're tracing that full chain of safety events as well. So to make sure that we essentially don't violate our own safety cases. And for this, it again goes back to making sure you have a very comprehensive and important safety case that you're actually working towards.
Yeah, so my answer to that would be, I think the approach should be that we clearly separate the AI system from the safety system, so that if the non-safe AI eventually gets hacked or does something unexpected, that we still have a second layer which can jump in, which is deterministic, which is proven by statistical measures, and have eventually a TÜV certification for something that that really was undergone a validation process. And those systems, they have to be prepared to jump in if something happens on the layers above.
I think we need to figure out the governance, right? Things will happen, and we will need to be able to jump in. But with time, again, we need to figure out how we decide when we, let's say, pull the plug and who's in charge and what we need to react to.
Exactly. So my next question was going to be actually, should a government be able to pull the plug on an AI model if they don't work out? And how does that work, right? So in our case, I mean, in Minerva, we deploy humanoid robots on critical assets like oil rigs. If you pull the plug on the humanoids, then they just collapse and actually create a massive safety hazard. So that obviously is not a solution to the problem, and there's not really an obvious solution. What do you guys think about this? Who should be able to pull the plug, and how should that work?
I personally, I prefer to assume the attackers, they will have access to those powerful models. Yeah, at least with the similar capability. Yeah, so the defense really cannot depend on the tool availability or model availability to the attackers, right? We get to be prepared. And unfortunately, there is no single silver bullet. So what we're doing is we're trying to build a system for our security loop engineering. Yeah, attackers will scan your source code or your binary using those powerful models. So why not you scan first, right? You raise the bar, right? You try to minimize the attack surface for those unknown. And you try to detect those unknowns by anomaly detection in the runtime. And you try to generate the security incidents with context, what happened before and after in your continuous monitoring system. And you keep improving through the cycles, right? So that's my answer. We cannot depend on the availability, the tool availability to the attackers.
So you ask what should happen if somebody pulls the plug. So my view on that from the functional safety perspective is it doesn't matter who pulls the plug. If there's a power failure, if there's a communication failure, if the system got hacked, if somebody shuts it down on purpose, what we have to make sure is that if this happens, that if you have a balanced humanoid, it does not fall over uncontrolled. So our approach is to have it fall at least nicely, so we cannot prevent that this goes wrong, but at least we can make it fall away from persons, for example, or crouch in a compact position instead of full speed crashing towards a person on the floor. So this is all measures to prevent the risk we expose to humans.
I think in addition to that, we also need to have a governance and regulations in terms of what a safe failed state is. So for a humanoid, if it just collapses, if you have a home robot, you definitely don't want that to collapse on a child or something or anything along those lines. You want to make sure that as an industry, as we deploy these technologies, get them to proliferate more into industry, into consumer spaces. As a regulatory body and as an industry, we really define how these systems are supposed to fail, when those fail measures go live. And as Florian said earlier, making sure we have an architecture in place that allows the system to fail. So if something is compromised, a backup system can take over and ensure the correct failure and the intended failure instead of an unintended failure.
I don't think I have much to add, but I do strongly feel there should be a second redundant separated system from the AI that can pull the plug and also come to let's say, a safe landing.
So to summarize, there should be a certifiable way of having some safety procedure that we follow in case there's a breakdown. And if there's a breakdown, then there should be a lower layer safety level that should be potentially defined in the silicon or in the hardware. What would that look like, or what does that look like at Synopsys at the moment?
Yeah, I mean, we're really focused on introducing the safety layer at the silicon level, right? And then you have things being stacked on top. So then you have firmware, you have the operating system, you have the AI model itself. And if something goes wrong, you really need to set up processes so that if something goes wrong, you can really trace where the problem came from, so you can work towards resolving it, making sure it doesn't happen in the future.
Yes, I support it. Safety, functional safety is a pyramid. So you have to start from the hardware layer, from the compute, from the firmware, from the actuator safety features, and then you can stack on top of that maybe safe camera inputs, and then add software layers for detecting persons, for calculating kinematics of a humanoid, for letting it fall in a nice way, and then everything on top of that sits the AI. which potentially also needs a monitoring system on the safety side. But you cannot start, you cannot have a safe humanoid if you don't start with the lower level of these safety pyramid, with safe actuators, with safe camera inputs. No chance. So safety is not just a sticker you can put on a ready deployed humanoid. You have to start from the beginning.
I think on top of the hardware root of trust, it's also important to run software in the loop simulation with your actual robot URDF or USD in a simulation environment. That's the only way you can tell, can your robot fail safe when a certain software component is being compromised. Yeah.
And I think the more layers of the stack that you add, and if you don't run your safety workflow through these layers, you're just pushing it deeper in, which later adds to a compounding problem. So in the design process, this needs to be something that is taken into account as the product is built up.
Great. There seems to be some disagreement actually in the panel about whether safety and security should be coupled or whether it should be separated, and whether there is benefits or sort of potential threats arising from them being coupled or separated. So I actually want to ask the question, can we honestly certify a system being secure without having a safety certification on it, or vice versa? Can we actually do a certification for one but not the other? Should that be a possibility, or should we only have certifications for both at the same time?
That's a good question. So you cannot have either or. I think it needs both in the end. It's just a question of how are they stacked on top of each other. So in our opinion, the functional safety part, so making sure that if something fails, that we fail safe and don't create risk for humanoids, that's the very lowest layer. And then security probably comes on top of that to prevent that somebody gets access to the humanoid at all.
I agree with Florian. I think it is a layered system, right? So if you do have a certifiable, safe, a functional safety system, so that tells you how the system is supposed to fail, exactly what your safety goals are, you can then add the security layer to make sure that in the event of those being triggered, you have a fail-safe mechanism. In an ideal world, you never see your functional safety mechanisms in work because things are secure, your security system is as good as it can be, and no one's ever hacked it. But the truth is that in some cases, they will be hacked, and when they are, we want to make sure that there is a security system, a safety system that comes in to save the day. So it is a layered stack, and I do believe that the entire system needs to be certified with a safety and a security flow.
I think.
Yeah, I agree. You need to have both. In my mind, security can be done. It can be isolated from safety in terms of establishing if the system is secure or not. But then the safety part analysis has to say assume that security has been breached, right? And then make sure that you handle it in the best way. I mean, in my mind, I'm thinking of the aerospace fields or even driving, right? We have humans in the loop, which we cannot fully predict the behavior of. I mean, somebody may just fall asleep at the wheel or have a heart attack at the wheel. The safety system needs to handle such a situation. So for me, it's a similar thing where we cannot guarantee what the AI will do, but we need to create a safe system nonetheless.
Awesome. So just in the interest of time, my final question is, what do you guys see as the biggest gap that the industry is currently ignoring, where you think that gap should be bridged ASAP?
From my perspective, it's about cybersecurity. Yeah, I know most of the robot makers, they are still focused on functional safety. That's the reality. Yeah. But again, I think cybersecurity is the foundation of functional safety, right? So without cybersecurity, it's really hard to guarantee your function safety can work under undeterministic cases. Yeah.
Yeah, I think bridging the security and safety gap is what the industry isn't working on right now. The typical process is build what you have, first do a safety certification because that's what you need to deploy, and then last step, you run a security workflow. As these models get more complex and the products get more complex, I think that is something that would set you up for failure. So having this be an integrated process where you're able to actually make sure that your safety and security are linked, you understand your end-to-end safety and security posture is going to be very important to deliver a successful product.
Yeah, so maybe I'm oversimplifying now, but what does it take to build a humanoid? You need the physical AI. So the AI part, that's data and AI models. I think that's covered today in industry. So at least everybody's talking about that. Also building physical robots, that's what everybody is doing. So that's solved. But what is not addressed today is the functional safety part. And that's the third dimension, which I think you need to address to get the humanoids out of a cage and operate in factory environments, in semi-public environments, and eventually also in private homes someday.
I'll just second that.
Awesome. Thank you all very much for your input. Really appreciated this chat. Thank you all.
Thank you.
Thank you.
Thank you.